Hello, everybody. I choose this topic because industrial application of machine learning are, let's say, the poor cousin of this type of application. I don't know why, but there are probably many reasons. One of the reasons could be that many amazing algorithms that were published since 2012 are coming from the R&D of the GAFA, and the initial application are not for manufacturing industry. Another reason could be that this type of application are struggling with a data quality problem that are as old as machine learning and even more, and are not solved yet. And so this talk is not just to complain, but also to give you an idea of what are the difficulties, what are the challenges and the potential. And also the elements that I will give you are maybe not universal. They are maybe based by our context in Saint-Gobain. And so if you don't know what Saint-Gobain does, just a short presentation. It's a company that was created many centuries ago by Louis the XIV, and the first job was to create the mirror and the glasses of the Versailles Palace. And since then, the activity changed a little bit. The company became worldwide, one of the 100 first company of the world. We still produce glass, but also other construction products like insulation, mortars, and plasterboard. Okay. And also we distribute this product with company like P in France, for example. And to run this activity, we need a lot of R&D. These are our R&D center all around the world. And I work in the Paris R&D center. And there we have the data lab, which is a data science lab, 25 data scientists. We apply machine learning to marketing and sales, and this is our most successful application. Also to building science, this is probably the funniest. Is there that we learn a lot about comfort, energy consumption, etc. But also to industry 4.0, and this is probably the most difficult. This is why I choose this topic. So first of all, a short definition. Industry 4.0 is a marketing buzz invented by Bosch 7 years ago, but is still in use, so it means that it catches something. And the idea is that we want to use the fact that in the production line we have many computers and sensors, new data, and we want to use new algorithm and also a cheapest connectivity to put all this data together and create a smart manufacturing line, basically to be more reactive, to do some preventive maintenance and so on. These are the, let's say, the opportunities. It's not just about automation, it's more about to have a robust production, to have smaller batches, smaller lot sizes, to have more customized product, and to help operators to take the right decision. And I like this slide coming from the Aachen University, even if it breaks the second rule of the good data scientist. The first rule is never show a pie chart in 3D, and the second rule is never show bar chart in 3D. But this is not a bar chart, it's more a staircase. And it shows the 4 steps toward Industry 4.0. The first one is to collect the data and show the data in a multidimensional way. This is something that is not easy for the operator that mostly use Excel. Then to build some machine learning to understand how the feature, how the process parameter are connected to the target, like for example the quality of the production. Then to use the predictive model to do some prediction. And then at the end, when the model is really mature, use it to control the process. But this slide also shows that the prerequisite is connectivity. And connectivity is really important, and all the difficulties are there. And you understand why, because if we play a game and I ask you which one of these two pictures show a real plant and which one is a marketing dream, I think you guess what is the answer. In this version, the plant is all connected and the operator allows the information thanks to a virtual version of the plant. And in this one, the operator is somewhere here in the middle of a machine that were installed 10 to 5, even more years ago. Nobody knows how they work, how they are connected, and it's still a complicated environment. So connectivity, what we are talking about, the difficult part is not to collect the data and send it to new cloud solution. The difficult part is an old problem, which is the connection with the PLC, the programmable logic controller, which are basically small computer that takes the data from the sensor on the line and bring the data to the SCADA system. The reason why it's complicated, it's because we have some technical depth about hardware. Usually a line is a patchwork of many different machines, and they come with different PLC. You can see a different type of PLC. Some of them are very new, others are very old. This one is totally burned. And the data coming to the SCADA, then to the cloud solution, it's not easy to have the right data to build machine learning that is reliable and give value to the operator. But this talk is not just to complain, but also to show some solution. One of them is edge computing. The idea is basically when you have a situation like that, basically if your plant is not a new plant built from scratch and you have an heritage of different ages of PLC, an idea could be to add a new computer. For example, this one is a Dell one with a software in it, able to connect to the PLC without disturbing the system because the system is delicate. And this computer get the data, sent to the cloud, and also what is interesting is that they can receive the machine learning model in a Docker container. For this example, we use a Loop Edge, which is a software developed by a startup, but there are many other like Ignition, Fieldbox, etc. But this is to say that when we look at the typical workflow of a digital project for the industry, the first part, when you do the data diagnosis before to actually build the machine learning model, the first part in the collect part, which is the place where you decide if you want to add new data to your data set, this part could be also about hardware. So this is why you need a team, and in this team you don't have just IT and data scientists, but also sensor expert and people from the line. So we use this slide before at the start of each project to be sure that the sponsor knows that we need all these people together in a team to go further. And the main risk that I observed is that very often we tend to forget the user, the client, because in the industrial world, the actors are engineers. They are not marketing guys, so they don't think about the user. Another risk is that the industrial IT are very often local and they have many things to do. So sometimes they are squeezed for a given project. Another problem is the data scientists, when they meet this hostile environment, tend to be a little bit to keep the distance and stay in the cloud instead of a link with the field. And another problem is that the data owner, people that assert the quality of the data, is a somehow fuzzy character in this team. Just to show you what data owner should do in an industrial project. The data owner is the person able to explain to the data scientist what the data mean. Because when we collect data from the raw data set collected by the PLC, they look like that, they have a strange name, and only the data owner knows what these data are. In this case, it's a temperature. It is important to know where this temperature is measured in the lines. Not so easy, because the sensor was installed 20 years ago, and nobody keep the memory of what this variable means. So in this case, it's a temperature. Also, it's important to know, to have a physical intuition of where are the limits of this sensor. For example, the red part are sensor failures, the production stops, or they actually are the signal that we want to use. So this is the job of the data owner, and the interaction between the data owner, the expert of the line, and the data scientist help us to clean the data. Talking about the data, we are not dealing with big data. If we look at the model, a model for a given machine, very often the data size is very small. We are drifting toward big data, mainly because we are using more and more deep learning for image recognition and also sound recognition for predictive maintenance, but we are not there. Talking about the tool, I use this slide coming from RIT. The RIT has an encyclopedical taste for showing all the possible software, but I use this slide just to scare people, but also to show that there are commercial and open source solutions, but also to take a decision in this jungle. I show this slide that show different solutions in use at Saint-Gobain when we move from the data connection toward data visualization, from data toward information. And the core part, which is the data preparation and the machine learning, is mainly done in Python, because when we talk about data coming from the production line, each line has his own specificity, his own technical depth, and we need to code to prepare the data in the right way. I don't find that there are some automation. This part is really coding and interaction between data scientist and plant expert. Just to conclude, a few examples. If we take again the staircase, the first step is visibility, to show the data. As I said before, the operator, in many cases, they never saw the data in multi-dimensional. And for example, the first step that we do is to show all the features that we have, process parameter, together. So we collect the data, we put the data in pandas, for example. Then we use some correlation. In this case, we use MIC, which is a nonlinear correlation. And each point is a feature, a process parameter, and the link between the feature, the strength of the link, give an idea of how these parameters vary together. And for this, we use Mike Boxstock D3GS script, which is very nice, is dynamic. Otherwise, we put that in bokeh. In this case, it's a bad luck. The product quality, this is what we want to explain, is not correlated with any process parameter, but this is why they call us. The second step, of course, is machine learning. Typical example, this was for a plasterboard plant. They want to understand and minimize the energy consumption. So we collect the data, we do data cleaning in pandas, and then we use, in this case, scikit-learn to do a machine learning model to show what are the parameters that actually has an impact on the energy consumption. And then, in this case, it's important also to show why these are the importance, and we use, in this case, SHAP to show how each parameter has an impact on the target. Then, in other cases, we want to predict what will happen. This is an example from another type of plasterboard production in Germany. In this plant, they had a problem because it's a very old plant, and they need to produce a new product, and this product was a little bit different. And thanks to the simulation, we were able to show that if they keep the same setup, they will have collision between the board, and this is not okay. So they asked us to optimize the conveyor parameter to avoid collision, and to do that, the first thing was to collect the data in pandas, then use SymPy to do the description of the dynamic of the conveyor. This is a dryer, and then you have some elevator, and the whole simulation is shown using this. And then, thanks to that, we were able to find where are the problems, and we use Pulp, which is a interface between Python and combinatorial optimization solver like Gurobi. And thanks to that, we were able to optimize the sequence of the elevator and avoid collision. So the takeaways is that connectivity of the line is the main problem, and this is why when we build a team, we need a multidisciplinary team, because probably we will have to collect new data, installing new hardware. Another important point is keep control of your data, and also what I try to send as a message is to avoid black boxes. We work with a lot of external partners, and what we want to receive at the end is the code, because in the code we can add our knowledge of the process. So that's it. Thank you for your attention.
So while the next speaker sets up, yeah, well, the next speaker sets up, we can take one question.
Yeah.
Thank you for the presentation. An example of a marketing use case with facilities maybe not offline, but production.
Of marketing? For example, we created a new business, which is a double-sided market between the customer and the craftsman, because we observed that in many cases it's very stressful when you want to refit your house, because you don't know which will be the best craftsman to do the job. So we create a sort of Airbnb that put in connection craftsmen and a client, and we have a machine learning in production that do the match between the needs of the customer and the best craftsman, also according to the availability of the craftsman, the position, the type of the job, etc. This is a machine learning working online. An example.